Okay, students, good evening. We are going to discuss our practice paper 11 for 2027 A-level batch. Okay, so look at the first question. It is from scientific discoveries. Okay, first one, radioactivity and existence of three types of radiation were discovered by Henry Becquerel and Ernest Rutherford respectively. Okay, so radioactivity was discovered by Becquerel. That's a very easy thing we discussed in our first few days. And the existence of three types of radiation was discovered by Ernest Rutherford. So that first statement is correct. Okay, so what are the three types of radiations we have? Three types of radiation we have: alpha, beta, and we have gamma. And then the second one says atomic nuclear model and proton were discovered by J.J. Thomson and Ernest Rutherford respectively. So that is wrong, no Lama. Atomic nuclear model was introduced by Rutherford. Okay, so nuclear model, planetary model. Actually, there is a small difference between these two. Okay, both were introduced by Rutherford, but nuclear model was the first one. After doing the what we call gold foil experiment, he found out the existence of nucleus. No? He said majority of the atom is empty. There is a small central positive nucleus. He didn't said anything about the electron movement. So that's where this picture comes. Okay, but planetary model means he explained how electrons will go. Okay, so if this is the atom, he said that electrons are moving around the nucleus like planets are moving around the sun. So in one orbit, there will be one electron in his theory. Okay, this is different from our Bohr model, because in Bohr model, what it says, there will be several electrons orbiting in one orbit. Okay, so in the first energy level, there will be 2. In the second energy level, there will be 8. So the picture is different. Looks similar, but it is different, right? You get that one, Nama? Hmm? So planetary model and nuclear model, that was suggested by Rutherford. And it says and proton was discovered by again the same scientist Rutherford. Okay, Rutherford. So therefore the second statement is wrong. So you have to say atomic nuclear model was and proton both were presented by Rutherford. Okay, so Thomson is not involving here. So what are the things Thomson did? Thomson actually he introduced the plum-pudding model. Remember, after discovering electron, okay, he did several experiments to get the properties of electron. Okay, he found out the E over M ratio and what are the other properties that are exhibited by cathode rays, and then he proved that cathode rays are electrons. So by including that particle, he changed the model of atom into plum-pudding model. Remember. J.J. Thomson is important in those areas. Electron, plum-pudding model, E over M ratio of cathode rays, like that. Okay, and he did a very considerable role when finding isotopes also. Okay, so for the discovery of isotopes, I will be having two scientists. Remember, Thomson and Aston. Okay, so Thomson is a part of the discovery of isotope. Right, so remember those things for the second statement. I hope that is not that difficult. Understood? So the first one is correct, second one is wrong. So let's go and see about the third one. In the third one, properties of cathode rays and positive rays and atomic number. So there are three things telling. That is wrong. Why? Cathode rays properties were discovered by Thomson. That is acceptable. But positive ray properties were discovered by another scientist. Can you all tell me who discovered positive ray properties? Yeah, Eugene Goldstein. Very good. Okay, Eugene Goldstein. Okay, so write down that. That's why the third statement is wrong. Okay, positive ray properties, it's E over M ratio, and everything was discovered by Eugene Goldstein. Okay, and atomic number was discovered by Moseley. Right. So last week we discussed about atomic number because it was important in the discussion of the periodic table. So I hope the first question is not that difficult. So let's save some time and go to the other question. Okay. So if I just quickly tell you who are the scientists that were discussed here. We discussed about Becquerel, Rutherford, then Thomson, then Eugene Goldstein, and then Mosley. Those are the scientists we had to the discussion here. So I added another small point. That is, this is a nice to know thing. Okay, Lama, this they will never ask this one for the 11. Okay, this is a nice to know point. We should know that nuclear model, planetary model, we are using both terms, no? But those are telling you different things, right? In planetary model, they are moving like planet, but that model is different from Bohr model. Okay, so that's the small story. Okay, right now let's go to the second MCQ. Select the correct statement. So this is basically from our last week discussion about periodic table. Look at the statements. So they're asking the correct one. So there are 4 statements incorrect. So I'll tell you for each statement why it is incorrect. You have to add that one to the review. Okay. Let's look at the first one. It says the periodic table introduced by Dmitry Mendeleev is based on atomic number. So that is false, no? So it is based on what actually? Is it based on atomic number? No. It is based on the mass of the atom. Okay, atomic mass. Right. So right in front of the first one is wrong. Why? Because first periodic table based on atomic mass. Atomic mass. Okay. And then our modern periodic table. Modern periodic table was based on atomic number. So therefore, the first statement is wrong. Right. Now look at the second statement in our second MCQ. Okay, barium is an alkali metal while rubidium is an alkali earth metal. In our periodic table, for certain groups, we have special names. For example, for group 1, we call them as alkali metals. For the group 2, we call them as alkali earth metals. Group 17, we call them as halogens. Okay, like that we have special names for certain groups. And for the group 15, 16 also there are names, but they are not important for us. But this alkali metal and alkali earth metal, that is really important, because even in A-level exam, they are starting the question by telling X is an alkali earth metal, like that. So then you should know what is meant by alkali earth metal. Okay, so group 2. So why this statement is wrong? So you can find our barium. Barium is a group 2 element. Group 2 element, no? So if it is group 2, that will be alkali earth metal. Okay, it's wrong. So they says it is an alkali metal. That's right. So again, you will find rubidium in group 1. So that will be alkali metal. Okay, so that is the mistake with the second statement. Now go to the third one. Third one says electronic configuration of ground state antimony atom is more stable than tin and tellurium atoms in the ground state. Okay, so if you go to the periodic table in our paper, actually I added a periodic table. So let's go and check that one really quickly. You can find out these antimony and other things. Okay, so you can see here SB and TE. These are the three elements we are discussing here. So now, if you take these 3 elements, so what they're asking is the SB out of these 3 elements, the group 15 element is having a stable electronic configuration. Okay, now what is the electronic configuration for the group 14? Group 14 electronic configuration is NS2NP2. Remember, group 15 NS2NP3, 16 NS2NP4. So out of those configurations, it's very simple thing actually. We know that NS2NP3, the P3 configuration is stable. Okay, because according to the Hund's rule, you know, electrons are singly filled. And if the sub-energy level is fully filled or partially filled, then it will be stable. So S2, P3, P6, D5, D10, those will be stable electronic configuration. So telling that antimony is having a stable configuration is true. And this is how you should find the answer. You are not going to write the antimony configuration, okay? You use the periodic table and see what is the group that antimony belongs. Okay, SB belongs. So it is belonging to the group 15. So all of the group 15 elements are sharing this common configuration. So therefore, if nitrogen is having this one, phosphorus is having this one, this Sb also should have the same configuration. Okay, you all know that nitrogen is stable like that. Antimony also stable relative to the adjacent element. Very simple thing. Now you can see how to use the periodic table also. Understood? Right. I hope there's no problem with that one. So that statement, third one is correct. Third one is correct. Okay. So now let's write down why other two statements are wrong. Okay. In other two statements in our paper, for valence electron of any atom, effective nuclear charge is less than its nuclear charge. Okay. Effective nuclear charge equals to nuclear charge minus shielding effect. You know that, for example, any element, say lithium or something, right? So lithium valence electron feels a lesser nuclear charge than the nucleus actually charged. Okay, so nucleus actual charge is +3, but this one feels less than +3. So why it is feeling less than +3? Because there are inner energy level electrons. Those electrons are shielding our considered electron. That is the reason. So that we call the shielding, the screening is called as the shielding effect, the covering effect. Okay. So therefore, any multi-electron system has a shielding effect. Even helium has a shielding effect. Remember, helium also having a shielding effect. So therefore, any multi-electron atom, okay, exists for any multi-electron atom. But there is only one element, hydrogen, with only one electron is there. So there is no shielding effect for hydrogen. Only for hydrogen, shielding effect is 0. Therefore, ZDFF is equal to Z. Okay, for hydrogen we can say that. Understood that one, Lamai? So that's why our fourth statement is wrong. It says for any element, this should be low. Okay, but it is not true for hydrogen. So you said that one very good. I'm very happy. Let's see why the fifth one is wrong. Fifth one, it says potassium valence electron has higher effective nuclear attraction than the effective nuclear attraction of sodium atom. Okay, so sodium and potassium, if you take them, they belong to the same group of the periodic table, group 1. So you have lithium, sodium, potassium, rubidium. Likewise, they all are in the group 1. Okay, so what happens downward the group? So downward the group, okay, downward the group, Z increases and shielding effect increases. ZEFF also increases. Remember from last week, ZEFF is also increases. But remember, effective nuclear attraction force, FEFF, is the only thing that decreases. That decreases downward the group. Okay, so therefore this statement is false. Potassium feels higher effective nuclear charge, but it doesn't feel higher effective nuclear attraction. Understood? Potassium feels a lesser effective nuclear attraction. Because why? Because this FEFF depends on ZDFF and radius. So as the radius increases, what will happen? The radius effect is also squared, no? So when radius increases, is FEFF decreases downward the group. Okay, so for you to understand what I am telling here, I'm just summarizing this one, right? You have to have a good idea regarding the our last week session. It is a very important thing. Like I said, okay, there are few theories in our A-level chemistry that are somewhat, students should try to grasp that one. Okay, so there are easy theories and there are hard theories like any other subject. Okay, in chemistry, this is the best theory you are finding in the first unit. Effective nuclear charge, attraction, those things you have to think, no? You have to understand, right? And there's a nice logic behind that. Okay, because when we want to understand about what happens to the periodic properties across the period and downward the group, for example, if you want to understand what happens to the ionization energy, then you need these theories. That's why. Okay, so take your time and study that one. Shall you go to the next question, third one? It's about first ionization energy. Increasing order of the first ionization energy of atoms. Okay, nitrogen, neon, sodium, phosphorus, argon, and potassium. So they are asking to analyze that. Okay, so if you check the places of these elements in the periodic table, okay, you will find now in our period table we want like group 3, so period 3, period 4 elements are there, and second period elements are also there. Nitrogen is somewhere here, phosphorus is in the third period, and argon is in the noble gas, and you have potassium here, sodium here, and there you have neon. These are the places that they belong. Okay, so sodium is there in the group 1, nitrogen in group 15, and neon in group 18. Are their groups. Now you know the configuration of these elements, because once you get the group number, you can think about the configuration. Okay, so sodium is in the third period and first group, so its configuration will be ending with 3s1, and potassium 4s1. So removing these electrons are really easy. Okay, why? You should supply energy, but still the energy will be lesser. Okay, why? Because they are having a large radius, therefore the attraction felt on that electron is low. So therefore it is easy to remove electrons from sodium and potassium, especially from group 1 elements. Okay, so ionization is relatively easy. But you can see in the other hand, these are noble gases, and neon configuration is 2s2 2p6. Okay, and this one 3s2 3p6, and we call them as group 18 noble gases because they are having very stable configuration. So removing electrons is difficult now. So then ionization energy will be high, and here ionization energy will be low. So now check the answers. That's my method today. But after discussing this theory part properly in our class, we can do this question in another way also by drawing the graph. But I'm not going to draw the graph today because I didn't discuss that one yet. Okay. So by analyzing the groups and all, we can think about the answer. Okay. So our noble gases should have highest values. Now, if you check the answers, okay, the noble gases are having higher values, but which noble gas should be the highest? Neon should have the highest value because its radius is low. Okay, you can say more nuclear attraction, because it's a small atom than argon. So therefore, removing electron from neon is really difficult. Then you have to have argon. So the answer should end with neon. So there are 3 answers ending like that. Okay, then you have to check for the easiest one. So removing electrons is very easy from this because it is having a higher radius. Okay, so least nuclear attraction. So according to this one, potassium should have a lower value than sodium. Okay, then in between you will be having nitrogen and phosphorus, but we don't have to worry about that one to find the answer because there's only one answer that starts from potassium and ends with argon. Okay, ends with neon. So the answer is answer 5. Is that clear? So starts with potassium, ends with neon. Okay, Laman? That's how you find the answer. Think about this one. This is some review we can give to the third question. Shall we go to the next question? It's about electronic configuration. Now, these 2 questions, question number 4 and 5, are from electronic configuration. So it's about arsenic. Since you know the periodic table location of arsenic, you can see that is there in the 15th group. Okay, in group 15, these are the 5 elements you have in the group 15. Okay, you don't need to memorize this one. Because you are anyway given a period table for the exam. Okay, but eventually with the time, with the practice, you will remember this. Look at the question. Consider an atom of the element arsenic in the ground state. So the first 5 electrons with the highest energy. Okay, so they take arsenic atom and they are asking for the first 5 electrons with highest energy. Highest energy. So now that means we need the arrangement of electrons in arsenic, which means, in other words, we need electronic configuration of arsenic to answer the question. Okay, so we know that arsenic is in group 15. Okay, and this is the second period, third period. Arsenic is in the fourth period. Okay, so which means we can get the final configuration of arsenic, because group 15 are showing NS2NP3. No? So therefore arsenic should have NS2, 4S2 and 4P3. This is the configuration of arsenic. Without writing it from the very beginning, we can use it. Okay, because in this question they are focusing on the first 5 electrons with highest energy. 5 electrons with highest energy. These are the electrons with highest energy. So they are asking for a quantum set belong to one of these 5 electrons. Okay, so if you are asked to draw these electrons, normally we draw them according to this diagram, isn't it? We draw them according to this diagram. But look at the electronic configuration, look at the quantum set they gave. They gave a quantum set, no? That the given quantum set is 4, 1, 0 and minus half. Okay, so 4, 1 indicating that they are belong to the 4p sub energy level. Okay, and what this minus half represent? What this minus half represent? That represents lamai counterclockwise spin. Okay, counterclockwise. That means the electron in the fourth, now they draw the, we can draw 4p like this now, and minus 1, 0, plus 1, these are the orbital now. And in the middle orbital there is an electron which are spinning to the counterclockwise direction. So that given electron is spinning to the counterclockwise, not clockwise. Understood that logic? That the given electron they gave spinning in this direction. So what about the other 2 electrons that are there in these orbitals? How they should spin? How they should spin? They should spin in the same direction. Why? Because according to Hund's principle, okay, spin of electrons must be parallel. Okay, if one electron spinning to the clockwise, then others must also spinning to the clockwise if they are filled 1 electron per each orbital. Okay, now the given electron is spinning to the anti-clockwise direction, so therefore other 2 electrons must spin to the anti-clockwise direction. So therefore we can eliminate one answer. That's the important thing. So if you take the second answer, it is also representing a 4p electron. 410 plus half. 410 plus half is not going to be there. Okay, so therefore this quantum set is, this is wrong. But this is wrong for this atom. Okay, so they are considering a given atom. For that atom, electrons are spinning anti-clockwise. Okay, but normally we draw like this, maybe another atom having this way. But for this given atom, electrons are spinning in the anti-clockwise direction. Okay, so therefore it should be the plus half is wrong. Understood that? But check the other quantum set. Look at the last answer. 4, 1, minus 1 and minus half. Minus half. No, it is same spin. So this one is correct. This one is wrong. Okay, is that clear to you all, Lama? Is there any doubt regarding this one? This is a very good question. Huh? A very good question. Some of you asked about this one in the class also. Right, but in this question I gave as an answer, another answer also. I gave marks for another answer. Why? Okay, because I gave marks for this one. 4, 0, 0, minus half. So 400 minus half is there in 4s sub-energy level. So why did I had to give marks for this one? Because I didn't expect this to be an answer, okay? Because I had to give marks anyway, because the question is asking 5 electrons with highest energy. Understood? So then 4s also is an keeping electrons. Understood? So if you want the 5 electrons, then you need to include 4s. That's why I had to give marks for this question also. Okay, but it is not the highest energy, yeah? Not the highest, but they are highest 5 electrons, then you have to include this one. Okay, it's a matter with the language. Understood? Right? So this is also belong to these electrons, these 5 electrons. Therefore, I had to give that one as an answer too. But now you can say about answer 3 and 4 also. So 3 in answer 3, you have 3, 2. 3, 2 is 3D, no? 3D electrons are not the highest energy for arsenic. Arsenic has 3D electrons, but they are in the inner energy level. Then you can't take a fourth one also, it is 4D. 4D is not there for arsenic. Then we can go to the next question, question number 5, which is another good question. The pairs of species with equal number of electrons with angular momentum quantum number L equals 0. It's asking species pairs of species with the equal number of L equals 0 electrons. So now they asking the question according to quantum numbers. No? So we have to convert that question into our language. Our language means without quantum numbers, we have to rephrase this question. Okay, so what is meant by L equals 0? L equals 0, L is standing for the azimuthal quantum number. Azimuthal quantum number will have numbers from 0 to 0, 1, 2, 3 like that, depending on their shape of the orbital. Okay, if it is an s orbital, then L value will be 0. Okay, if they are p orbitals, then they are going to be 1. D, L value will be 2, like that we know. So now they are asking L equals 0. L equals 0 means S sub energy level. Okay, so now you have to consider these elements given, and you have to select which pair of elements are having same number of S electrons. That's the question they are asking. Okay, so which pair of elements, I'll write that one. Which pair of elements or ions, same number of sub energy level electrons. That's the question they're asking. Okay, is sub energy level electron. Right, now when you want to answer this question, okay, so now imagine you are in the A-level exam. Okay, there are 50 questions to answer. Okay, so these questions that are coming from the first unit, second unit, you have to answer them fast, because by the time you go to the exam, these questions will be really easy. Okay, right now they might not be easy to you because you are just started now. You have to understand that. Okay, Lama. But when you are going for the A-level exam, when you are going to the A-level exam, these things will be very easy, right? And you have to figure out a way to do this question fast without spending much time. Okay, so now one student might think, okay, I should write the electronic configuration of these elements, and then I should take the electronic configuration of iron, right? Iron means if they're asking about the scandium 3 plus, then you are writing scandium, then take the scandium 3 plus configuration. You are writing that again. Okay, but that method will give you the answer. But the problem is what? It will take much time. Okay, spending too much time on one question is not that good. Yes, you are given only 2 hours to answer 50 questions. The average, if you do the math, you can see maybe 2 minutes and 20 seconds, 30 seconds will be there for one question. Okay, so if possible, we should save time also. Right? If you can do this question fast, let's say within 1 minute, then you can use that extra time to another question, because there will be chemical calculation 5 or 6 questions also. So then you can use that time to do them. because obviously calculation questions will take time. Okay, so like that thing. Now I'm going to show you how to do this question without writing configuration. Okay, so those who did this question, some of them might have done the way I'm going to do, but some students may have write the full configuration. Okay, but study this method, right? Study this method. This is only for MCQs, right? Only for MCQs. Okay, right. Get this. Now take the answer 1, vanadium and scandium 3 plus. Vanadium and scandium 3 plus. Okay, now you remind the atomic number of vanadium. You don't have to remember that actually. You can go to the periodic table and check it. Vanadium is there in the 23rd place. Okay, so then its configuration will be 3D3 4s2 and scandium 3 plus. Scandium 3 plus. Scandium electronic configuration is 3D1 4s2. But when it is making plus 3 cation, all these 3 electrons will be removed. Isn't it? All these 3 electrons will be removed. Now, don't count s electrons. Look at the thing there in the board. Okay, look at what you got. Okay, according to this, vanadium is having 4s electrons. Okay, but scandium is not having 4s electrons, which means can their s electrons count will be similar? Will that be similar? Will they be same? No, because this one obviously will have lesser number of s electrons. You don't want to write 1s2, 2s2 like that. This is obvious. Is that clear? So therefore, this will not be an answer. Like that, analyze. That is my method. Without writing the full configuration. Okay, so when you are writing this one as a review, okay, add a sentence also. Now look at the second question, second option. They give potassium and calcium. Calcium 2 plus that, isn't it? Huh? Now potassium electronic configuration will be 4s1. That's how it is ending. And this will calcium will be 4s2. But when it make calcium 2 plus, these 2 electrons will be gone. So then there are one element is having 4s electrons and other one is not having 4s electrons. See, electronic s electrons will not be the same. So this is not an answer. Understood? Huh? So I'll anyway write a statement for this one. It will be beneficial for you because when you are going to write it, some students may get confused, right? Okay, so this is the thing. So vanadium has 4s electrons, but scandium 3 plus does not have any 4s electron. Okay, so therefore total s electron count will be higher in vanadium than scandium 3 plus. Like that, you can give a sentence also for the thing you saw here. Okay, so like that you can analyze. Okay, now let's go to the third one, which is our answer. Fe3 plus and copper plus. So what's the configuration of iron? Iron electronic configuration will be 3D5, 3D6 and 4s2. 3D6 iron 2 plus. Okay? 3D6 and 4s2. So when it make iron 2 plus, these 4s electrons will be gone. And copper electronic configuration is 3D10 4s1. So when it make copper plus, this 4s1 electron will be gone. So I didn't write the full configuration. Okay, Lama? I skipped 1s, 2s, those things because it is a MCQ. So then both are having only what? Both have 1s2, 2s2, 3s2 as s electron. You can write regarding the our fourth answer and fifth answer, then you will see the same thing. Okay, you see the same thing. So if you take chromium plus and argon plus, chromium 3 plus and not argon, silver plus, silver is in the fifth period. So silver will have more electrons than Ag plus is having more electrons than chromium 3 plus, because this one is having 1s, 2s, 3s, and 4s also. Okay, but this one is only having 1s, 2s, and 3s. That is wrong. Fifth one is also wrong. Why? It's cobalt 3 plus and scandium. Cobalt 3d7 4s2. So then when it makes the plus 3 cation, 4s will be gone and this will be converted to 3d6. And scandium will have 3d1 and 4s2. See, cobalt 3 plus is not having 4s, but scandium will be having 4s. Like that, think, analyze quickly using your brain, okay, and then get the answer. This is where, okay, your thinking is important. In last week class also, I told you regarding this, processing power that you have to process, when you are going for those professional life. Okay, so when you are going to become a doctor or an engineer, especially, I'm talking about those two professions because those are the most common, ambitions you are having, right? And other than that, there are many good professions. Okay, but just talk about when you focus on them, right? Those two professions, you have to have a good processing power in your brain, right? Because you are going to deal with, important problems. Okay, your decisions are affecting, patient lives, whether the patient is going to live or die depending on your decision, right? Then you have to think, right? Then you have to find solutions fast, you have to analyze, right? You have to have that skill. Okay, so in A level, this period, this 2.5 year period, we are kind of training you to have that skill. Okay, that is called as the critical thinking. You might have heard it. Just you have to improve that one. Okay, so let's improve our critical thinking. Now you analyze the problem, you find the shortest way to get the answer. This is according to my perspective. So you might have another angle of this question, another way of finding the answer for this question. Okay, so there it may happen for many questions because I'm just uh, presenting my method of getting the answer, right? But there may be many other methods, right? So if you get the answer according to such method that is not discussed here, so you always can come to me and ask whether that method is correct. Okay, please do that one. Okay, so don't just take the method I am giving, right? Just think using your brain. Okay, just practice this one because you can now do mistakes and you can now learn from them. When it is closer to the exam, don't try to do mistakes and learn because it is too late. But now it is not late. You have more than 2 years for your exam. So use that time, do mistakes and learn from them. Okay, do mistakes and learn from them. Question number 6. In question number 6, we have a chemical calculation. And it's a long question and it is not difficult, right? It's long but not difficult. 1.7 grams of pure sample of sodium nitrate. You have NaNO3 pure sample, 1.7 grams. Okay, and you are thermally decomposing that. They gave the chemical reaction NaNO3 decomposed to give you NaNO2 and O2. Okay, and if you balance this one using the inspection method, there will be 2 and 2 in front of this. Right, okay, how many moles of NaNO3 was there? We'll simplify the question as we go along. And first of all, we need the molar mass of this compound. Okay, molar mass of NaNO3. So 23 plus 14 plus 16 into 3. Okay, don't use this 2 only. It is not relevant for the molar mass. Okay, so if you add them, you will get the answer 85. 85 grams. So then how many moles of NaNO3 is there? So 1.7 gram divided by 85, you can see it is divisible because 85 times 2 is 170. Okay, 85 times 2 is 170. So it will be 0.02 moles. Okay, so if you have 0.02 moles, you will be having oxygen 0.01 moles. Okay, so we need this oxygen amount for the next question. And then it says this given oxygen was then reacted with 0.084 pure lithium metal. So from that we can take lithium moles also. So moles of lithium will be 0.084 gram division 7 gram per mole. It's divisible by 7. 0.01 for like 14, you'll be having 2. Okay, so this is the number of moles of lithium. So then it says when it is reacting, within bracket you can see until the limiting reactant is consumed. Okay, so it says lithium oxide is given. So there is a chemical reaction again. Chemical reaction. So lithium is reacting with oxygen to form lithium oxide. Now again you can use inspection method to balance this. You can put 2 in front of this and 4 here. So 4:1 ratio, they are reacting. So now for this type of a question, we are applying ARR method. Remember, added, reacted, and remain. Okay. So we have added here 0.012 moles. And from oxygen, we have 0.01 mole. Okay. And you have to find what is the limiting reactor. Okay. So to react with 4 of lithium, we need 1 of oxygen. Okay. To react with this whole amount, we need 1/4 of this amount. That means we need only 0.0003. But we have obviously more than that, no? Therefore, oxygen will be the limit excess reactant and lithium will be the limiting reactant. And here you will be having 0.006 moles. Okay, so here it is fully consumed, 0.007 is remaining, and this amount of lithium oxide will be formed. And then it is telling you add this one to water. You add this lithium oxide to water. Then you are getting lithium hydroxide now, 2 of them. So if you added 0.006, you will be having 0.012 moles of lithium hydroxide. Okay. Then it is telling we are reacting this lithium hydroxide with H2SO4. So lithium hydroxide with H2SO4, we are going to form lithium sulfate and 2 water. Okay, so they are reacting in 2:1 ratio. 2:1 ratio. So to react with 0.012, you will be needing 0.006 moles of H2SO4. So they are asking the volume of H2SO4 we need. So volume is equal to moles over concentration. 0.006 you have to divide by the concentration 0.3. 60 division 3, 20 centimeter cube. 20 centimeter cube. Okay, it's a good question, isn't it? It's long but not that difficult. Question number 7. This is a past paper question and we discussed the theory part relevant for this one in our last week class. Okay, remember about the concentrated acid question ID. So I'm going to use a different method today, okay, to do the question. Percentage of ammonia that we have. So 30% by mass. 30% by mass means if you take 100 grams of solution, 30 grams will be ammonia. That's what they mean. Okay. And then you have the density. Density is 0.85 grams per cubic centimeter. That means if you take 1 cubic centimeter of the solution, 0.85 grams will be there from the total solution, total mass. Okay. Right. Then they're asking when 400 cubic centimeters. So you are taking 400 cubic centimeters of solution. Okay, and then you are adding that one with H2SO4. So if you add H2SO4 with ammonia, what will be formed? There will be a reaction. Ammonia with H2SO4 will be forming NH4 twice SO4. This one is not given actually, no? It says only ammonium sulfate. You have to find the formula of that. But this is for the A-level paper, no? By the time you go for the A-level, you will know this formula, okay? So anyway, we'll be needing 2 of this. So 2:1:1 ratio, it is reactive. Okay. So now let's do the question. Okay. So let's find mass of 400 cubic centimeter of solution. That's the first thing we can do because our volume is 400. Remember last week I took the volume as 1 decimeter cube. Okay. But today we are taking 400 cubic centimeter. Okay. So the mass will be 0.85 into 400 grams. You can see when you multiply them, units will be cancelled. Okay. And then out of that total mass, you can find mass of actual ammonia. Mass of NH3 will be 0.85 into 400 into 30%. 30% is the actual ammonia mass. Then we need the ammonia moles. No? So moles of ammonia will be, you have to divide this one by its molar mass, 17 grams per mole. Then you will be finding the number of moles. Okay. Now you can see they are reacting in 2:1 ratio. No? So then you can find, and they are forming ammonium sulfate also 1. Okay. Then you can find how many moles of ammonium sulfate will be formed. Right. So then moles of ammonium sulfate, it's going to be 2 times like this. Okay. 2 times like this. Let's simplify this one some here. It's too long, no? Can cut this one. Then 1785, there will be like 5, 0.05, 6 moles. Then moles of ammonium sulfate will be 3 moles because half of it. If you have 6 moles of this one, you will be having 3 moles of this, no? Half of that. Simple stoichiometry. Then what we need is not the moles, we need the mass of ammonium sulfate. So again, we have to multiply this number of moles by molar mass of this one. What is the molar mass of ammonium sulfate? Molar mass. There are 2 nitrogen, so 28, 8 hydrogen, 8, 32, and then 64. 16, 22, 2, 4, 132. So you have to multiply this one by 132 grams per mole. It's going to be 396 grams. Answer is answer 2. Okay. So then this is the normal method I am advising you to do. Then what is the short method? So you're not going to write this whole bunch of statements in the A-level exam, right? So then how do we do this one with less time? So the secret is you're not going to write the statements. You're thinking about the question and you're going to put all these numbers into one row. So now at the beginning, you have this 0.85 grams. No? So 400 into 0.85. This is the mass of solution. Okay, now think with me. This is the mass of solution, right? From this mass, 30% is ammonia. Then to get the number of moles, you divide this one by 70. Divide this one by 70. And then half of the ammonia moles, you will be having ammonium sulfate. So half of this one will be, you have to multiply by half. So divide by 2. Then they asking the mass, no? So you have to multiply by the molar mass, which is 132. And this is going to be the answer. Isn't it? In a level exam, you are not going to write the statement. And you are getting this one in single line. You have to practice until that. Is that clear? So if you simplify it and cut and everything, you will get the same marks. So let's go and discuss question number 8. So here this one is U92 238 and it is converted to RA 88 226. It's asking what is the suitable combination, right? The suitable combination is answer 4. I'll tell you more about this. But however, I'm going to show you how to get this, right? And the difference here is 4, decreased by 4. And here the difference is 12. So it's not obviously going to be the 2 alpha particles, no? Right? And you can apply these given combinations to this one. Okay, whether they will satisfy this difference. And then you can say those are wrong, right? For example, take the second one, second option. Second option says 4 alpha particles. Alpha means 2, 4. And the other one is 2 neutrons. Neutron is 0, 1. Next one is gamma. So gamma is doesn't have any charge or mass, 0, 0. So what's the sum here? 4 into 4 is 16 and 2. So there here the difference will be like 16 and 2, 18. And the proton number, this is the nucleon number increase or decrease, and this will be the proton number decrease, 8 here. This is not going to be the answer. Like that, you can eliminate. Therefore, second one is wrong. Second option is wrong. Like that, then apply. If you apply the next one, I mean our answer, the fourth one, 2 alpha particles, 2, 4. And then 4 neutrons, 4, 0, 1. And then 5 gamma particles. You can add as many as gamma particles you want because no problem, they don't have any charge on it. Just add them here, these numbers, including this one, and 2 into 2, 2 into 4, 8, 8 plus 4, 12. And if you check about this set of numbers, you'll be having 2 into 2, 4. So then that's our answer. Okay, so therefore fourth one is correct. Question number 9 and 10. The emission spectrum is not dark lines in bright background, it's the other way. Dark lines in bright background is what? Absorption spectrum. Okay, emission spectrum is colorful lines in dark background. Okay, so at that one, that is wrong. A is wrong. Why? Because it is colorful lines in dark background. So B is true because Balmer series is basically they are in the visible region, no, but Lyman series is fully ultraviolet, no. So therefore it should have a higher energy than Balmer. Okay, so Balmer is having a low energy. That statement is correct. And if you take the C, absorption spectrum is discontinuous. Discontinuous means lamai, you will see lines. Absorption, emission, both are discontinuous. So basically you can write this one, huh? Write this. Any atomic spectrum, absorption or emission, any atomic spectrum, absorption or emission are discontinuous. Any atomic spectrum, it may be absorption or it may be emission, anything, right, is discontinuous. Discontinuous. Or you can say line spectrum. It consists of lines. Okay. So therefore, C statement is correct. And look at the last one. It says it's a long statement, but it is the first part is going very nicely, right? They says electrons are coming back to the first energy level in Lyman series, but see how they finish it. They are finishing the sentence by telling Lyman is belonging to the visible region. So therefore that one is wrong. Lyman is not there in the visible region, right? So where you can find Lyman series? You will find Lyman series in ultraviolet region. So therefore that one is wrong. Incorrect ones are A and D. No? A and D. No? So A, D answer is answer 4. Okay, Lama? Answer 4. So I added in the message, it has answer 2. Sorry, okay? For the both questions, answer is answer 4. Because they're asking the incorrect answer. A incorrect, B incorrect. B and D are also incorrect. Sorry, A, D incorrect, so answer 4. Next question also the same. Now look at the 10th one, atomic structure. Yeah, obtaining a clear shadow confirms that cathode rays are going in straight lines, not the kinetic energy thing, momentum thing. So which experiment proves that they have momentum? Can you send a message? Which one tells it is having a momentum? Which experiment? Which experiment shows? Yes, rotation of the wheel. Rotation of the, we say light paddle wheel. Yeah, good. Okay, so if you place a paddle wheel in the path of cathode rays, it starts to rotate. Okay, so it is because of the kinetic energy transferred from cathode rays to that wheel. Okay, so A is correct. So A is wrong. Sorry, it's wrong. And look at B. de Broglie wavelength of SO2 at V speed is equal to the de Broglie wavelength of O2 at 2V speed. That's correct. Why? Because de Broglie wavelength lambda is equal to H over mv. So if you take SO2 de Broglie wavelength, you can say it's H over 64 into V. But if you take de Broglie wavelength of O2, it will be H over 32, but speed is 2 times, no? But then, however, it is going to be what? 64V. So that means both are having the same values, no? Therefore, de Broglie wavelength must be same for those two, SO2 and O2 molecules. Okay, the lighter one travels 2 times faster like the heavier one. So it's some mathematical thing. Second one is true. Go to the third option. Yeah, canal rays are deflecting perpendicular like other positive particles. That is true because canal rays are actually positive nuclei of atoms. So that's true. And look at the next one. Last one, why it is wrong. Very few alpha particles came back or bounced back because of the strong repulsion from the nucleus right there and there. Not because of the collision with electrons. That's wrong. Electrons are never going to collide with this. Okay? Electrons will knock out, right? So you can say D is wrong. Why the D statement is wrong? Because you can say alpha particles are bouncing back due to strong repulsion from the nucleus. Okay, that's why alpha particles are bouncing back, right? Not because of the collision with electron. That's not true. Right, so those are the 10 questions that we discussed today. I hope you got this one really well. If you have any further doubts regarding this one, you can ask that one. So complete your reviews. Write a good review for this one. Okay, and we'll see next week class with our next paper. Okay, so good night everyone. Study well.